Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video, we learned the last and an important question of exercise number 1.1 related with the matrices and equation. Today we are going to start a new exercise number 1.2. The first question tells that write transpose of the following matrix. So in transpose, the column and the rows are interchanged with each other. So how can we find the transpose for the first part of the question number 1? Our P matrix is 1, 2 and 3, 1. So in transpose, the rows are changed into column. So here this 1, 2 is in row, so it will convert into a column just like 1 and 2. And in 3, 1, this is also is in the row, so it will convert to the column just like 3, 1. So this is our transpose. We will write it just like P power T, capital T. Now here it is Q. So Q is equal to L, M and N, P. So the transpose L, M, it is in row, so it will convert into a column. It becomes L divided by M. In row L and M. Here N and P is in row, so it will convert into a column N and P. So this is the transpose of Q. Here it is one column and one row. So 1 cross 1 order matrix A2. So in transpose, the rows and column are interchanged. So its order will be just like 1 cross 1. So it will not affect. So this is the transpose of the given matrix. Here the order of the matrix is here 1, 2 and 3. Here is 3 rows and 1 and 2. Here is 2 column. So in transpose, this order will be changed. It becomes 2 cross 3. So it means in this matrix there will be 2 rows, just like -5, -2. And 4 and 3 column. So 1, 1 and 4, 1, 1 and 4. So this is the transpose. Here there is 2 rows and 3 column. So it becomes S power capital T is equal to, here this column is changed into row and this column is changed into row. Here move to part 5. Here 6, 7 and 8 it will convert into a column, so it becomes 6, 7 and 8. And 13, 1 and 3 it will convert into a column, 13, 1, 3 and 2, 4, 5 it is in row, so it will convert into a column, it becomes 2, 4 and 5. So this is our question number 1. Now move to the question number 2. It tells that which one of the following matrices are transpose of each other. We have given 4 parts, 1, 2, 3 and 4. Over here there are 4 different matrices, and that tells that which 2 matrices are the transpose of each other. So out of these 4 matrices, 2 and 2 matrices will be the transpose of each other. So let's check out first and second matrix. So our B matrix is A1, B1, A2, B2. So its transpose will be just like B power capital T is equal to, here A1, B1 is in row, so it will convert into a column, it becomes A1, B1. A2, B2 is in row, it will convert into a column, so it becomes A2, B2. So if we look on A matrix, it is A1, A2, A1, A2 and B1, B2 and B1 and B2. So B matrix transpose and A matrix, these are equal to each other. So it means that A and B matrix are the transpose of each other. And now let us take the transpose of the fourth part D, so it becomes D power capital T is equal to, here minus 3, 1, minus 1, it will convert into a row, so it becomes -3, 1, -1 and 4 to 7 will convert into a row, so it becomes 4 to 7. So D matrix transpose and C matrix, these are equal because here it is -3, 1, -1 and it also -3, 1, -1. It is 4 to 7, it is also 4 to 7. Both are equal. It means that C matrix and D matrix are the transpose of each other. So this is question number 2. Now move to the question number 3 related with exercise number 1.2. It tells that which one of the following matrices are symmetric. Symmetric matrices are those matrices in which a single matrix is equal to the transpose of that matrix. This is the basic definition of symmetric matrix. Let us take the transpose of part 1. So it becomes A power transpose mean capital T. So here 5 minus 7 is in row, it will convert into a column, so it becomes 5 and -7. 1 minus 1, 5 is in row, it will convert into a column, so it becomes -1 and 5. So this is A transpose. If we look at A transpose and A matrix, here it is 5 and here it is -7, here it is -1, here it is -1, here it is -7, 5 and 5. So these are not equal to each other. A transpose is not equal to A. So this is not the basic definition of symmetric matrices. So this is not a symmetric matrix. Now let's check part 2. So B power capital T, check the taking transpose, minus 1 and 2 is in row, it will convert into a column, so it becomes minus 1 and 2. 2 and 3 is in row, it will convert into a column, so it becomes 2 and 3. Now look at B transpose and B matrix. And B matrix, here it is minus 1, here it is minus 1, here it is 2, here it is 2, here it is 2, and here it is 3. So A B transpose is equal to the B matrix. So this qualifies the basic definition of symmetric matrix. So it means that part 2 is a symmetric matrix. Now taking the transpose of part 3, so it becomes C power capital T is equal to 3, 4 will convert into a column, 5 and 6 will convert into a column. So here it is 3 and here it is 3. So here it is 4 and it is 5. So these are not equal. C power transpose is not equal to the matrix C. So this is not the basic definition of symmetric matrix. It means that part 3 is not a symmetric matrix. Now check part 4. Taking the transpose D power capital T, convert 1, 2, 3 into a column and 4, 5, 6 into a column. So here it is 2 rows and 3 columns, and here it is 3 rows and 2 columns. So the order are not same. It means that this is not the D power transpose is not equal to D. So this is also not the basic definition of symmetric matrix. So this is question number 3. So this not satisfy the basic definition of symmetric matrix. It means that this is part 4 result not a symmetric matrix. So this is question number 3. Move to the question number 4 and the last question of exercise number 1.2 related with the chapter matrices and determinant. This tells that which one of the following matrices are skew symmetric matrices. So skew symmetric matrices are those matrices in which the transpose of the matrix is equal to the negative time of the original matrix. So now let's start with part 1. Our matrix A is 0, 4 and minus 4, 0. So its transpose will become A power capital T is equal to 0, 4 will change into column, it becomes 0, 4 minus 4, 0. It is in row, it will convert into a column, it becomes minus 4, 0. Now this is A transpose, and we know that the skew symmetric matrices in which the transpose of the matrix will be equal to the negative time of the original matrix. Original matrix is A, so multiply minus with it, so it becomes minus 0, minus 4 and 4 and 0, 4 and 0. Here we can take it positive 0. So A transpose is our A transpose is 0, minus 4 and 4, 0, and our A matrix is 0, minus 4 and 4, 0. So A transpose is equal to negative time of A, both are equal, so it means that the first matrix is a skew symmetric matrix. Now taking the second part, B matrix is 0, minus 5, 5, 0. So taking the transpose, so it becomes B power capital T is equal to convert 0 minus 5 into column, it becomes 0 minus 5. Convert 5, 0 into column, it becomes 5 and 0. Now multiply negative with a given matrix B, so it becomes 0, positive 5, minus 5 and 0. So this is minus B. So here it is 0, 5, 0, 5. Here it is minus 5 and 0. So B transpose is equal to a negative A. So it means that this matrix is also skew symmetric matrix. Now taking the third part, here the matrix C is 0, 7, 7, 0. Taking transpose C power T, it becomes 0, 7 will convert into column, 7, 0 will convert into column. So 7, 0. Now multiply negative with the given matrix C, so it becomes minus C is equal to 0, minus 7 and 0. So minus C and C power transpose are not equal because here it is plus positive 7 and here it is negative 7. Both are not equal, it means that this is not a skew symmetric matrix. Now taking this matrix and taking the transpose, so it becomes D power T, 0, 3, 2 will convert into a column, 0, 3, 2, minus 3, 0, 1 will convert into a column, minus 2, minus 1, 0 will convert into a column. So this is the transpose. Now multiply minus with a given matrix, it becomes minus D is equal to 0, minus 3, minus 2, positive 3, 0, negative 1, plus 2, plus 1 and 0. So this is minus D. So here it is 0, minus 3, minus 2, 0, minus 3, minus 2, 3, 0, minus 1, 3, 0, minus 1, 2, 1, 0. D power transpose is equal to minus D. It means that this matrix is also a skew symmetric matrix. With this question, exercise number 1.2 is completed. Inshallah, in the next video, I will start exercise number 1.3 related with chapter number 1, class 9 mathematics, matrices and determinant. Thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification of mathematics. Thank you.